In this question, it is given, we measure the period of oscillation of a simple pendulum. In successive measurements, the readings turn out to be 2.63 second, 2.56 second, 2.42 second, 2.71 second, and 2.80 second. Calculate the absolute errors, relative or percentage error. Now, before we get into this, let's have a look at what a simple pendulum is. A simple pendulum is nothing but a bob that has been suspended using a string. And the oscillation, to and fro oscillations of this, is what we are going to measure here as the period of oscillation. Now, to begin with, they have given us 5 readings that are there. So n is equal to 5. And we need to calculate the absolute error. So in order to calculate the absolute error, what we can do is, we can start by taking the mean time. So T mean will be nothing but summation I is equal to 1 to 5 Ti by n. That means I'm just going to add all the times and divide it by the number that is there. So that is going to be 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80, the whole divided by 5. Now this value that is there, the sum of all this, we end up getting it to be equal to 13.12 by 5, which I will get it as 2.62 seconds. Now, in order to find the absolute error, we need to know what are the errors first of all. They have only given us the time. They have not given us plus minus delta t. Now, delta t here is going to signify the error. So, how are we going to find the error is, whatever value is there, we are going to subtract it from the mean time. And this would give us our error. So, for instance, let us look at the first value. It is 2.63. So, 2.63 minus 2.62. This is equal to 0.01 second. That means my time is, measured time is 2.63 plus minus 0.01 second. So it can be less by 0.01 or it can be greater by 0.01. So this is the error that is there. Similarly, we will have to calculate the errors in all the values. That is starting from T1, T2, T3, T4 and T5. Minus 2.62. So very crudely we can say that our values that are there, we can find the plus minus error. Now since all of these values are there, we can actually calculate how much it is differing from the mean value. So we have 0.01 for the first, minus 0.06, minus 0.20, 0.09, 0.18. So these are the values by which our readings are differing from the mean value of 2.62. Now, in order to calculate the exact error that is there, where I can tell that 2.63 plus minus, in order to do that, we will take the average of this value. That is, let's say mathematically, we can call it as the arithmetic mean. So I'm just going to take the mean here, which would mean I'm going to ignore the negative signs that are there and take only the magnitude. So that I will get it like this. So 0.01 plus, I've got 0.06 and 0.2 plus 0.20 plus 0.09 plus 0.18 whole divided by 5, which will be 0.54 by 5, which is equal to 0.108. Now this we can write it as 0.11 second. So rounding off, I'm writing it as 0.11. Now, what is the understanding? So if I take my first value of time that is there, that is the final mean that we found, which is 2.62. This is going to be plus minus 0.11. That means the value that I have can range from 2.73 to 2.51. So this is the range in which the measurement can happen. Now how did I get this? It was nothing but 2.62 plus 0.11 and 2.62 minus 0.11. Now we can actually look at this. There's no point in rounding off the last values. But in other terms also, the first decimal place, since we are taking time, the first decimal place is very significant when we are measuring time. So we can write our actual value, that is the absolute error, as 2.6 plus minus 0.1. That is along with the error. So now the next part is to calculate the relative error or percentage error. Now the formula will be nothing but delta A by A. This is for relative error. And for percentage error, you just multiply this into 100%. So here if we see, our value of error is 0.1 divided by 2.6, that is our time, into 100%. So let us see what we get on solving. This will be equal to 0.038 into 100%, which gives us 4%. So the percentage error, the relative error is 4, the percentage error is 4% in the measurement.